Good morning, good afternoon, good evening to all the delegates who are in this in Global Risk Symposium. I first of all thank the Dalhousie University for hosting this Global Risk Symposium. Myself, Abishek, here to present my PhD research of inductive cum targeted yield model-based integrated fertilizer prescription for hybrid castor. Globally, according to the IPC report, the scientists are observing changes in Earth climate and in the every region and across the world climate system. And due to this climate change era, the food production system is mostly associated with the climate and its change, and it is affected by this climate change era. India is the leading producer of the castor, where the world population is to be increased by 9.8 billion by 2050, and vice versa, the arable land per capita is going to be decreasing, and it is worse in the developed countries. To mitigate this challenge, we have to achieve a food grain production through following ways: through improved crop productivity, having a best water management practices, and improving cropping intensity, and adopting a best soil management practices. My research is on the fourth theme: using a best soil management practices. I'm likely to do a greater production of crops. India is the leading producer of the castor and the leading marketing of castor oil, which is an highest industrial importance. For the best soil management practices, the appraisal of soil fertility through the spatial and the temporal scale is the best management because it has highly biological relevance and economic relevance, and it gives a balanced nutrition to the plants and the soil. Ramurthy and its co-worker in 1967 developed a unique field experiment approach, which was followed by myself, was creating a microcosm of soil fertility variability within a microcosm of experimental field. In this experimental, there's in 4 phases. One is gradient experiment, second is a test crop experiment, third is validation experiment, and final is the field trials, which I'm going to explain in further slides. In gradient experiment, a field is divided into 3 strips, and in first strip, there is no fertilizer is added, and in second strip, a single dose of fertilizer is added. In the third strip, a double dose of fertilizer is added so that the artificial soil fertility gradient has been made. And after applying this fertilizer, an exhaustive crop like sorghum or maize is grown so that fertilizer undergoes transformation in the soil with plant and microbial agents. After this harvest of the exhaustive crop, we can observe there is a development of artificial fertility gradient. After the development of this fertility gradient, a set of 24 treatments, this is developed by Ramurthy and its co-worker. This set of 25 treatments and the level of nitrogen, phosphorus, and potassium varies with the crops. And for my experiment, nitrogen level is 45, 90, 135, and for phosphorus it is 20, 40, 60, and potassium it is 20, 40, 60. And having this 24 set of treatment, it is been incorporated in all the 3 strips, and across the strips, 3 levels of FOM is added. In first level, there is no FOM. Second level, 6.25 tons of FOM, and the third level, 12.5 tons of FOM is added. And across all the plots, an equal best management practices are followed throughout the crop. And you can see this field view. This is my field view at the peak vegetative stage, that is at 75th day after sowing. And you can see in the third strip, you can see a high vigorous growth compared to second strip, and in first strip, which is a low fertility gradient, you will get a lower crop growth. This shows there is a development of artificial fertility, and the crop respond to the artificial fertility. This is the development of this macrocosm of soil fertility variability within a microcosm of experimental field. And across the strip, you can see there is in the no farmyard manure strips, you can show a lesser crop production, and comparing to higher farmyard manure dose, that is 12.5 tons per hectare. Using this crop data, a following set of basic parameters has been used to develop this fertilizer prescription equation. That is nutrient requirement, that is for quintal per, for production of quintals of seed per tons, and this percent contribution of nutrient from the soil. Next, a percent contribution of nutrient from the fertilizer, and next is a percent contribution of nutrient from the organic manures. After getting these basic parameters, and the fertilizer prescription equation has been developed for inorganic fertilization practices alone and the inorganic fertilization with the FOM. This formation of this equation is followed by Ramamurthy and his co-workers papers, and having this equation we can make a targeted yield, because on farmers will have a resource constraint. Maybe they have this time due to fertilizer constraint they can have a lesser resource, and one in season they may have a higher resource, so that they can incorporate higher fertilizer, they can get an achievable target. Using this achievable equation, we can get achievable yield. And in the other validation experiment has been done using a set of 10 treatments, where you can, I'm making a 3 target yield, that is lower target of about 2.25 tons of per hectare of castor yield, and next is 2.5, next is 2.7, and similar 3 treatments along under the IPNS also has been followed. And it has been compared with the normal blanket recommendation and the blanket plus FOM recommendation and the basic farmers practices and absolute control. After this experiment, it can be seen that the according to this fertilizer prescription equation, the lowest target yield can be easily achievable. That is, percent achievement is higher comparing to highest target yield, but it is more than 10%, more than 95% of achievable to this target. And comparing to this fertilizer prescription based treatment, comparing to the farmers practice, there is a 65% of yield increase, and comparing with the blanket, there is a 30% of yield increase. This equation can be used for the farmers, and target can be set according to the resource availability of the farmers. And this equation is specific for each soil series, and this can be done overall throughout the world, but it has to be formulated for each particular soil series, and soil types has to be made. Thank you.